All right. Let me share the screen. Okay, ready? So we have already done we have already learned how to write the half equation. We already learned how to describe the change in the redox reactions. Okay. So today we're going to go something very important. All right. Okay. For the syllabus, we have got a few redox reactions, mentioned in the syllabus. So they'll only ask that. Okay. The first type of redox reaction will be the combustion, means burning of the metals. Can you see now? The metals are burned in air. Okay, I'm going to just share a video with you. All right. We'll look at the video now. Okay, just 1 minute. Okay. Okay. We are going. I'll share the screen, the video. Okay, ready? And also share the sound. Okay, ready? All right, observe first.
Hello scientific people, how are you today? So today I'm going to show you the demonstration of a chemical reaction, that is burning of magnesium. So here I have a strip of magnesium which is cut from the magnesium ribbon. So this is the magnesium ribbon.
Wait, notice before that, this is a strip of magnesium ribbon. You can see this one is a bit dark, but here it's a bit shiny. So whenever you do any experiments with magnesium, you have to clean the magnesium ribbon first. How you clean it? You use sandpaper to remove the layer of the oxide. Okay, and then what he's going to do? So he's actually going to burn the magnesium. So combustion of magnesium means burning of magnesium. So he's going to use the tongs here, all right, and he's going to put it under the Bunsen flame. Okay, so this is a chemical equation. All right. Okay,
and this is Bunsen's burner and a watch glass in which I am going to collect the magnesium oxide, which is white in color. These are the pair of tongs. So when magnesium reacts with oxygen, it requires heat energy.
Notice something, oxygen must always be O2. I've seen students writing magnesium Mg plus O. So gas must be oxygen, O2, all right, and you'll get magnesium oxide. So afterwards, he'll take the magnesium oxide, he'll put it here, in the watch glass. I want you to see the color. And when magnesium is burning, observe the intensity of the flame. Ready? Okay.
And after initiating this reaction, you will see that the magnesium burns in presence of oxygen to form magnesium oxide, and magnesium burns in oxygen with a brilliant white flame. That is called a dazzling white flame. Very difficult to see that. So let's try the experiment, and here I am going to hold this magnesium ribbon. Actually, we don't require a very big piece of magnesium. It's very handy. You can even break it with your own hands. So I choose to put all other things aside.
Okay, observe that. It's turning down the magnesium ribbon. You can see it's a brilliant white.
As you can see that magnesium burns with a dazzling white flame.
Okay, so it burns with a bright, very bright flame, white flame. And look at the color of the residue. This is the residue.
Now as the reaction is complete,
this is the magnesium oxide. Can you see that? What color? Pay particular attention.
You can see that this white color thing is being produced. This white color is nothing but magnesium oxide.
Okay, the magnesium oxide is white in color. You see that? It's very clear there. And in fact, when the magnesium is burning, you're not supposed to look at it with your naked eyes. You're at least supposed to stand at a distance. Okay, too close, you'll damage your eyes. Because if the light is too bright, you'll damage your retina. Okay, all right. So right now to our new share. All right, we continue now. Okay, so this is the first. So burning of magnesium ribbon is a redox reaction. Okay, it's a redox reaction. You can see here. All right, this is a pure magnesium ribbon. You can see it's dark in color. You have to clean it, and then this when it is burning, and this is the residue. The residue is magnesium oxide. Look at the color, white in color. So let's answer this question first. We'll see why is this a redox reaction. So magnesium is burned in air. Okay, so magnesium plus oxygen, you get MgO. Of course, you have to balance it. All right. O2, so is, I put a 2 in front here, so 2O, 2O, 2Mg, 2Mg. So a chemical equation, you ask me write, you must write. Very common, always students, they put Mg plus O. And then some of them even don't put the correct chemical formula. You don't put MgO2. The correct chemical formula is MgO because Mg is 2 plus, O is 2 minus. So the chemical formula must be MgO. Okay, let's try that first. Okay. So I want you to do something for me now. Okay, I'm going to use see, can you see? Mg going to here. Okay, you do this first. And then the O2 going to here. Okay, can you do that arrow there first? Okay, and then Mg, okay, so as I told you, this magnesium oxide is an ionic compound. If it's an ionic compound, it contains magnesium ion. So that means here, this one will be Mg2 plus. Can you see that? Mg2 plus. Here it contains Mg2 plus, and here it contains O2 minus. Can you see that? Okay, observe it. So Mg becoming Mg2 plus. Can you see? Because it's an ionic compound. Okay, MgO is an ionic compound. So this is oxidation. 0 to plus 2. Mg is 0, isn't it? The oxidation state is 0. This is also 0. 0 to plus 2. Here, oxygen, O2 becoming O2 minus. Can you see that? O2 minus. So 0, also 0 to negative 2. So you can see 0 to plus 2 is oxidation. 0, negative 2, going to the left is reduction. Okay, so can we try this now? In this reaction, oxygen, all right, oxidizes, write that down. It will oxidize OXIDISE magnesium to magnesium ion. Write that down first. Okay, and at the same time, magnesium will reduce. Because you can see this process is reduction, correct now? So magnesium will reduce oxygen to become, okay, what is the name for this ion? Oxide ion, OXIDE. The name for the ion is oxide ion. So we have described in word what does oxygen do and then what does magnesium do. Okay, so now we write the half equation. Ready? You write for me now. We have already done this before. All right, how to write half equation? This is 0 to plus 2. So this is oxidation. Jaden, can you give me the answer to the first one? Mg and to Mg2 plus? What's the half equation? Jaden? Can you hear me? Satish?
O2 plus 4E arrow.
No, this one. Mg first. Jaden didn't give the answer.
Oh, Mg arrow, Mg2 plus 2E.
Plus 2E, isn't it? Yeah, this is your oxidation half equation. Okay. All right. You notice something? Here is O2, here is O. It's not balanced. So you want to balance it, you must put a 2 in front. 2O, O2. So this is 0 to negative 4. Can you see that? 0 minus 2 times 2 is negative 4. 0 to negative 4, you're going backward. Backward is reduction. Reduction in rig. Remember, oil rig. So obviously 4E here, if it's negative 4, it must be plus 4E here. Sorry, my mistake. Reduction, isn't it? Reduction is gain, so if it's gain, it must be plus 4E here. Plus 4E. Here is plus 2. So this, we have completed the half equation. This is the first thing you have to know that we will ask in the exam. Okay, burning of metals. Okay, the example that is suggested was burning of magnesium oxide. So done. Okay, so you can see magnesium is oxidized, correct? This is oxidation. So what is oxidizing agent? Put down oxygen. Or you just put O2, so is oxidizing agent. And then you can see oxygen is reduced. This is reduction, so your reducing agent will be magnesium. Simple, huh? Okay, first example number 1. Okay, we don't waste time. You go to number 2 now. The second one is the burning of magnesium in chlorine gas. Okay, I'm going to see the video now, but we also have an example here. Okay, sorry, burning of sodium. This one, what I have is I have a gas jar. And the gas jar, we prepare some chlorine gas. Okay. And then what we're going to do is we're going to take a piece of sodium, we're going to burn it. Okay. And you know sodium is a group 1 metal, will burn very fast. So when the burning sodium is then inserted into the gas jar, you can see the reaction here. It's a very vigorous reaction. Okay, so you're going to write down 2 observations for me now after viewing the video. Okay, but you can see from this picture here, you know, one of the first observation will be a very bright flame is formed, or there's a vigorous reaction. Second thing, I want you to keep a lookout for the oxide, for the product form, sodium and chlorine. Okay, ready? I'll share the video now. Wait 1 minute. Let me share the video again. Okay, let me share. Get ready? Second video. Okay, so you can see here. If you look at the gas jar, you can see it's slightly greenish yellow. So this is your chlorine gas. Okay, but of course we are not using sodium, we are using magnesium. It doesn't matter. Okay, the video was magnesium. Okay, never mind, doesn't matter. Alright, so just now magnesium in oxygen. Only now magnesium in chlorine. But the only one problem, this joker, this guy doing the experiment, he forgot to clean the magnesium ribbon. Maybe he was too busy that day, I presume. So you're supposed to clean the magnesium ribbon. If you don't clean and you burn, it will burn slower. It take a longer time to burn. If you clean it very fast with the magnesium ribbon and then with the sandpaper and then you put it in the gas jar, the reaction is very fast. Okay, ready? But again, metal with chlorine gas. It can be sodium, it can be magnesium. In SPM, they can ask that. They mention burning metals in chlorine. Okay, chlorine is a gas. You can see here it's slightly greenish yellow. Okay, let's observe. Ready? Yeah? Okay. Inserting it. Yeah? Oh, that was very fast, is it? But it's supposed to take its time. Maybe you're so scared of the chlorine gas. Wait, we'll do it again. Okay, I want to observe one thing. I'm just going to forward it a bit. Alright. Wait. Hold on. Oh, no. Wait. Here. Okay, wait. Sorry. You can see. When it's putting it inside, can you see that? It's a very vigorous reaction. Okay. The reaction is very vigorous. You can see, very vigorous. Okay, and then you can see once inside also it burns very brightly. So that's for your first observation. Okay. Second observation, I want you to pay particular attention to the, can you see that? That's your oxide, chloride. Magnesium burns in chlorine to form magnesium chloride. The residue is white in color. Okay? Alright, you can see that, that's your residue there. Alright, Alright, okay, so we continue now. We come back to our screen sharing. Okay, so let's do that now first. But instead of magnesium, they put sodium, so we just take sodium. Okay, no harm. Okay, can you write the chemical equation now? Sodium and chlorine. Do it now, all of you. Okay, I guide you. Sodium is Na. Okay, Na. Chlorine, as I told you, is a gas, so you must put Cl2. So only one product. Okay, sodium plus chlorine, you get sodium chloride. Na plus Cl minus, so the chemical formula is NaCl. Okay, that's it for me. If you do this, you still get 1 mark, Correct reactants, correct products. Then if you balance it, you get 1 more mark. Okay, try it now, all of you. Okay, let's check. 2 chlorine, so there's only 1 chlorine here, so I put a 2 there. Right? Okay, so 2Cl, Cl2. 2Na, 2Na. This is solid, this is a gas. Okay. So write down the 2 observations now for this experiment. The first observation, Elisa, one try. What's the first observation? What's the first observation? Just say magnesium burns one.
Sodium
burns one.
vigorously.
Okay, well, okay. Sodium burns very brightly or very vigorously. Okay, very good, well done. Write that down. So sodium burns very vigorously. Okay, Okay, then the second thing I told you, you look at the video. Okay, what is the color of the product form? Okay, who wants to try? Alicia, are you here, Alicia, today? Alicia?
Yes.
Okay, Alicia, answer for me. What is the color of the residue?
White.
Okay, write down. The residue is white in color. Of course, we know the residue is sodium chloride, but you don't say the sodium chloride is white. Right? Observation is, how do you know sodium chloride unless you test for it? So you just say the residue is white in color. But the second one, the first one, the sodium burns very brightly or very vigorously in chlorine gas. Okay, all right. Then we continue, huh? Okay, so this is the second one. Okay, so can you complete the half equation for me? Now, where you got the Na plus? I told you sodium chloride is formed. Sodium chloride is an ionic compound. So sodium will form sodium ions. The chlorine will form chloride ions. This NaCl came from the compound that is formed. It's an ionic. Okay, complete the half equation for me. You'll ask this just like that only. No, you have to know. You just follow exactly the syllabus. You just stick according to what the syllabus wants. You won't ask anything here. Okay. Who can try for me? Jiao, are you there, Jiao? Jiao?
Yes, sir.
Can you answer what's the half equation here? 0 to plus 1. So how you complete the half equation?
So you plus E at the behind.
Plus E. Well done, Jiao. Okay. All right. So anyway, you put down here oxidation. Loss of electrons. This one loses electron. Come here. Okay. This one, before you do this, you must make sure that the atoms are, all the atoms on the left and right side is balanced. Here is Cl2, only one Cl. Don't bother with the charge. So you put a 2 first. Kita balance, do a Cl, Cl2. Okay, so now this is 0, can you see? And then this is becoming negative. You follow the original number. The original number is negative 1. So 0 to negative 1, all right, will be going backwards. Is reduction. So reduction is gain. So this is minus 1 times 2. Okay, so you must put plus 2e. Okay, we have already done that the other day. Okay, so I'll erase this one so you don't get confused. Okay, so you can see Cl2 plus 2e F2. What type of reaction? Reduction. Okay. So you can see here, this is oxidized, this is reduced. So who can tell me what is the oxidizing agent? What is the reducing agent? Okay, let me check. Yongsin is here. Yeah, Yongsin, try Yongsin. What is my oxidizing agent and what is my reducing agent?
Chlorine is the oxidizing agent.
Okay, chlorine. Okay, very good. Or you can put Cl2 again or chlorine. Then what is my reducing agent?
So sodium.
Sodium. See, oxidizing, reducing comes from here, one of them. Okay, well done. Very good. Okay, so I clear. All right. Any questions so far? I think it's quite straightforward. Okay, we clear first. Okay, we go to the next one. All right. Okay, let me do this. Where is the clearing part? Okay, yeah. Okay, so settle. Okay, now comes the most important thing for redox. Because this one, all the one we learned earlier will come on to the multiple choice half equation on. This one is a famous section, paper 1 question, paper 2. Paper 2, either section A or section B or C. Where, all right, if it doesn't come out section A, it's going to come out the essay every year like that. So it's very, very important. You must know the color changes. Okay, so important redox reaction for SPM. The ones given here are the only ones that you need to know. The rest all no need to know. Okay, let's have a look first. You see here, I've got, this is iron 2. Can you see that? Iron 2, look at the color here. This one, I call it as pale green. P-A-L-E, pale green solution, or light green. This one is brown. It's supposed to be brown. Slowly it becomes brown. Later I'll show you the video. Okay, so what you're going to do this now for me. Here we have Fe2 plus to Fe3 plus. So what type of reaction? Is it oxidation or reduction? Alim, can you tell me, Alim? What type of reaction is this? Alim? Fe2 plus to Fe3 plus. Is Alim here today? Alim is here. Okay, Alim, tell me, apa jenis reaction ini? Oxidation or
Reply in the chat.
okay, okay, it doesn't have a microphone. Okay, oxidation. Well done. Write down your oxidation. Okay. Then what about description? Description you're going to put in words for me now. Write down. Fe2 plus, we call it iron 2 ion. Write that down first. You go slowly, don't worry. Iron 2 ions. Okay, Fe2 plus. Iron, put Roman numerals, 2. Is oxidized to form iron 3 ion. That's how you describe. Okay, so you can see here, this is pale green. Fe2 plus, try to put pale green or light green also can, changes color to brown. Usually you go for brown. Fe3 plus is brown in color. Okay, so you can see here, right? And why did I put 2 arrows here? Okay, this one is plus Fe2 plus, this is Fe3 plus. One you can label here, this is Fe2 plus, okay? All right, this diagram pale green, this one is Fe3 plus. Okay, you can label here. Okay, so you see this arrow, so this one is oxidation, you put oxidation. If you go from Fe3 plus to Fe2 plus, you can also do that. This one is your reduction. Okay, so iron 2 ions, iron 3. So you must know the color, very important. How to know, how you describe, you take the Fe2 plus is just like the color of your urine, you know. Alright, if you urinate and then you, in a small bottle, something, you put send your urine for medical testing, alright, or do a blood test or whatever, okay, they test your urine. If your urine is light, a greenish yellow like that, that is the color. You don't go and say urine color, so you just say pale green. So that's a word in the books most. You can say light green also they accept. But your Fe3 plus must be brown or yellowish brown. Just put brown in. Okay, so you describe in words. Okay, well done, Aliva. Okay, so we go next one. Okay, let me clear first. All right, then reverse now. Okay, Fe3 plus. Okay, what type of reaction? Write down. Just now 2 plus to 3 plus oxidation. Jain, are you here, Jain?
Yes.
Okay, answer. What type of reaction is this?
Reduction.
Reduction. Okay, put in words for me.
Iron 3 ion has been reduced to form iron 2 ion.
Okay, well done. Roman numerals, iron 3 ion is reduced to form iron 2 ion. So I want you to describe in words. Observation, this is your observation. Observation is a brown solution changes to green. You always want to see the color change for redox. Don't say solution form is green or what, we are going reverse now. All right, we're going reverse, that means reduction. Brown solution changes to green. Okay, then we go for the next one. Okay, clear? All right, we go for the next one. Okay, next one refers to this picture here. Okay, this one is your chloride ion. All the ions of the halogens, chloride, bromide, iodine, all are colorless. Okay, all are colorless. This is colorless, this is your chlorine in water. So aqueous chlorine. Okay, I want you to do some labeling now. Do some labeling here first. Put down chloride ions. Write it down in words. Chloride ions. Okay, IONS. All right. Symbol is Cl minus. Okay, this is your chloride ion. Colorless, In chemistry, you cannot use the word clear. Clear haram, They don't know. Clear solution cannot be colorless solution. Like water. Water is not clear. Water is colorless. Okay, this one is aqueous chlorine. Aqueous means in solution form. Or chlorine water also can. Chlorine solution accepted lah, but you just go for aqueous chlorine. Aqueous means soluble in water. Sorry, it's not soluble. I mean, it consists molecules. Okay, here I'm going to put some dots here. Here each dot is a chlorine molecule. All these are dots. This one, the dots here are your chloride ions. Can you see not? Cl minus. Each dot here is a molecule of chlorine. Okay. Ready, huh? Okay. What color? You can see the color. You can see is pale green, or greenish yellow. In fact, even Fe2 plus looks like this color. Okay, ready? So 0 to the original number, you can see a 0 here is 0. The original charge is -1. So type of reaction. Okay, who wants to try? Jaden, want to try, Jaden? What type of reaction? Reduction.
Reduce.
What reduce? I want the type of reaction.
Reduction.
Reduction, yes. Process is reduced, but type of reaction is not reduced. Reduction. Okay, well done. Can you describe in words for me?
Aqueous chlorine is reduced.
No need aqueous. Just go for the molecule. When you describe, you just go in terms of molecules.
Oh,
Go in terms of
chlorine
the
is reduced to
No.
chloride ion.
Okay. In terms of particles. So particles with chlorine is reduced to?
Chloride ion.
Well done. Very good. So when they ask you to do description, you describe in terms of the particles. Aku makan itik, remember. Chlorine or chlorine molecule is reduced to form chloride ion. Well done. Alright? So you can see, that means we are going this way, we are going backwards. Can you see now? Chlorine becoming chloride ion. So pale yellow solution, pale yellow changes to become colorless. Understand? We are going backwards. This one, So this description is for this reaction. Reduction here. Okay. Who can do the opposite one for me now? Sandra, you try the next one for me. Sandra? Let me clear. Wait, let me clear first. Okay, we're doing this one now. Okay, Cl minus, you're doing the one on the right now here. Okay, this Cl minus becoming chloride ion. Okay, what type of change is this? What type of reaction? And you see the, okay, you look at the chart here. This is -1, don't bother the 2. So it's -1 becoming, nothing here means 0, Sandra? So -1 to 0, are you going right or left?
Right.
I'm going right, isn't it? So right is what?
Oxidation.
Oxidation. Okay, so here you put oxidation. Write down detail. Okay. Type of reaction. Okay, now can you describe in words for me?
Chlorine ion is
No.
chloride.
Chloride ion. Yes.
Oxidized to chlorine.
Okay, well done. Very good. Okay. Chloride ion is oxidized to form chlorine or chlorine molecule or chlorine gas. Just chlorine. Well done, Sandra. Okay. All right. What's the color change? What's the observation here?
Colorless solution changes to become pale yellow solution.
Pale yellow, pale green is okay. Okay. Colorless solution changes color to become pale green or pale yellow is okay. Well done, Sandra? Good. So you all know how to put in words already, Okay, we go next one. That's clear. Okay, so you saw the two colors, One is for iron 2 plus. Okay, let me clear first. All right, you must know this. I'm telling you, very important. Iron 2 and iron 3, the color change. Then chloride ions and chlorine. Both also done, Okay. Now we go for this one. This is your bromide. I told you the ions or the halogens are all colored. Bromide, this is bromine. Okay, so we'll do this first, the top one first. That means bromine. Okay, label here first. Label here. Label this bromide ion. Didn't Tam Jason just join, You always come half.
Okay.
Okay, so note it down, please, Tam Jason is present today, okay. All right, at least he attended, and not like Terrence, Terrence always punting. Super also punting. What about Marcus Dick Hitchum today? Is he here or today? Let's check first.
He is here.
Oh, okay, Marcus is here. Okay, good. Well done, Marcus. Good. Okay, ready? Okay, we will try. Okay. Who shall I ask? Okay, Kalop. Okay, your turn, Kalop. You do the first one. Okay, what type of change is this?
Reduction.
0 to -1, Original one. So reduction. Okay, put in words for me. Continue.
Bromine molecule.
Bromine molecule is
reduced to form bromide ion.
okay. Bromide, BROMID. Well done. Okay. So you can see here, that means we are going backwards, we are going to the left. Okay, we are going to the left. From here to here, bromine becoming, again, I'm going to put some dots here. Dot represents a bromine molecule inside. Okay, aqueous bromine, this is aqueous bromine, this is labeled as this aqueous bromine, this is bromide ion. This colorless, this one contains molecules of bromine, or the dot. You can't see that, okay. So the color change is from brown, all right, to colorless. Brown changes color to become colorless. Okay, let's go for the next one. Let's see who can try it. I want all of you to try it now. Not always, okay. Who else want to try it? Eugene, try this now, please. Eugene?
Okay.
Second one, okay.
Oxidation.
-1 to 0, Eugene? Okay, what's the type of reaction?
Oxidation.
Okay, -1, 0, oxidation. Well done. Okay, put in words for me.
Bromide ion is oxidized to form bromine.
Okay, very good. Well done. So you can see colorless solution changes to brown. Ask for description, color. Okay, well done. Okay, settle. So this is the third one. Okay, now we go for the fourth one. Let me clear first. These are not all the ones I'm showing you. These are the only ones they're going to ask in your SPM. They're not going to go anything below that. Okay, beyond that. Okay, ready? All right, we'll try this one first. I clear first. Sini just joined, Jaden, Sini just joined. I think she was.
Sini was here since just now already.
She was here just now. I think maybe she went out. Okay, then we'll come back. Okay, no problem. Okay, ready? All right. Who shall I ask? Let me see first. Sean doesn't have microphone. Always, okay. Some of them, I mean, ask if they don't answer. That's what I know. Okay. Elaine. Are you ready, Elaine? Okay, try this one for me now first. Okay, first label here for some of you. This is iodide ion. This is iodine, aqueous iodine. This is the iodine you test for starch, you take 1 drop of this iodine, you put in starch, it turns blue-black. This is the iodine. Okay, this is very dilute. The concentrated iodine you apply on your wound, and then it's like hitting the moon. The pain is excruciating pain for a few seconds. Okay, ready? And then try.
Oxidation.
-1 to 0, isn't it? Oxidation. Okay, well done. You put in words for me.
Iodide ion is
Yes.
oxidized to form aqueous iodine.
Just iodine also can, or aqueous iodine. Okay, that one no problem. Well done. Very good. So colorless solution, that means we are doing this now. Okay? We are doing the forward reaction. Colorless solution becoming brown. Not brown, not orange. It must be brown. Okay, we do the reverse now. Okay. Who shall I ask? Okay, all. Let me see first. Avril. Avril, try Avril. A long time I didn't hear from you, Avril. Okay, try it now.
Reduction.
Okay, this one is 0 to -1. The original one is -1. So 0 reduction. Okay, put in words for me.
Iodine is reduced to form iodide ion.
Iodine is reduced to form iodide ion. Well done. Okay. Now put tell me the observation. Describe the observation.
Brown solution changes to colorless.
Brown solution changes color to colorless. Well done. See, all of you can do it today. Good. Because you must know how to describe in words. All this will be used in the other lessons, So what we are doing today is like a foundation for the next part of your lesson. Okay, good. Very good, all of you. Okay, done. Okay, now we come. So far, how many have you done? Check first. First one, Fe2 plus, Fe3 plus, Cl minus NCl2, Br minus Br2, I minus I2. Now comes a special one, purple color, All right. Okay, this one is a bit tricky. Okay, wait, I'm going to ask somebody first. Okay, Never mind, you just try. Okay, all of you tell me. Sean also can, or Alim also, Elisa, whoever, or Celine. Okay, Celine, you try. You tell me, Celine. What type of change is this? Addition or reduction, Celine? I'm going to discuss with you, but you make a mistake, no problem.
Oxidation.
Okay, you said oxidation. Wait. Why is it oxidation or reduction?
I think it's reduction.
Think why?
Because +7 to +2.
Where you got +7 from?
The MnO4.
Well done, Celine. You see, you cannot compare like this. All of you know. Just see all this. You see, we only involve one element. You see, iodine. Here also iodine. You can see now bromine. I mean, just see, all this one element, you know. But now, one atom, you can see now, you see two different atoms, you know. So you cannot compare -1 to +2. You cannot compare like that. You must compare like what Celine did. Well done, Celine. All right. You must compare the Mn and the Mn. Understand? You must compare like that. Okay. So remember that we worked out, isn't it? This is MnO4. You work out the oxidation state. This is +7. So +7 becoming +2. Can you follow me? That's what Celine did. Well done, Celine. So this is, you don't compare -1 to 2. So +7 to 2 is what type of reaction again, Celine? Is it reduction, Celine? Okay, it's reduction. Okay, that's one thing now. Okay, now the next thing is the problem. The words. Okay. MnO4 minus. I'll guide you. You know what's the name, Celine?
No, not sure.
Okay, write it down now. All of you, Okay, Elisa, you know the name, Elisa? What is MnO4 minus called?
Manganate ion.
Manganate, still wrong. Alicia Ong, why is she wrong?
Manganate 7.
Manganate 7, well done. Understand? Because you see, because there's also manganese 2, you know. So here, write down manganate 7 ion. Write down first. Manganate, manganate, put Roman numerals, put 7. Manganate 7 ion, Roman numeral, 7 ion. Is reduced. The reduction one, isn't it? Is reduced, you write R, okay. Reduced to, okay, this one is Mn2 plus, is called manganese, you know, this is the color for manganese. Actually, it's light pink, you know, but it is almost like colorless, you know. So manganese, Ganese. Manganese, don't forget, is Roman numerals 2. Manganese got +2, +4, so it's +2. Manganese ion. I repeat again, Manganate, MANGNAT, Roman numeral 7 ion is reduced to manganese, Roman numerals 2 ion. Okay? Well done, Elisa. Anyway, a good try, Elisa. It must be manganate 7. MnO4 special name, ingat ini. Selalu they'll ask. So observation, you can see this is purple color. This is oxidizing agent. It is decolorized to become, or purple color solution becomes colorless. You can even say purple solution is decolorized also, they accept. Purple to colorless, this one. This one looks like colorless, no, but in solution it becomes almost colorless. So SPM, they want colorless. All right. Yeah, somebody is asking me, why is it manganate 7? Okay, I'll show you. MnO4, isn't it? Then we learn, remember how to work out oxidation state. Remember? Okay, this one. So you work out your X, Mn, you're working with X plus -8. Correct now? O is -2, -8, and this is equal to -1. So X is what? X minus 8. So X will be +7. You saw that? +7. So that's why I say manganese 7. Because we are working on the Mn. Isn't it? You say manganese, wrong. Manganese 7 ion. Okay, you think? Alright? Okay. Then we go for the reverse now. Now the next one we're going for this. Okay, let's have a look first. Oh, this one only one way now. They won't answer the other one. SPM never answered. Okay, Padama. Okay, now we go for one more. The last one. Okay, for the redox reaction. Okay, this one. Alright. Okay, this one is, okay, I'm going to show you. Anyway, label this first. Okay, go back to this first. Label this first. This is manganese 7 ion. Label here, this is manganese 2 ion. Put Roman numeral. MANGANAT, Roman numeral, put 7 ion. Or manganese 7 solution also can. Here is manganese, MANGANES. It is a transition element. Put Roman numerals 2, Mn2 plus. Because there's no manganese 2, manganese 4, manganese 5 and all that. You understand? Oxidation. So that's why we put manganese 2. Okay. Done, Alright. Now we go for one more. This one. Okay. Okay. This one also. Okay. What type of a reaction is this? Is it oxidation? Let me check first. Who's around? Is Chu around? Okay. Chu Twin, tell me.
Yes.
Okay. What type of reaction is this?
Reduction.
How do you know it's reduction? But it's -2 to +3. What? How do you know?
The Cr2, the Cr is +6.
Well done. You see again, very good. You see, you must work out the oxidation state for chromium and chromium here. Don't bother the oxygen. If you work it out, okay, work it out and see all the others. How much you get? Let's try it now. For those who are not sure, okay, 2 Cr, so it's 2x, okay, plus, okay, -14. And this is equals to -2. Is that correct? You will get +6. From +6, you're getting +3. Can you see? So that's why Chu said that this is a reduction. Alright, this one is called special. Only these two, like MnO4 and Cr2O7, two special names, That's all summers. Okay, this one, the name is called, if you Cr2O7, your syllabus is dichromate. Remember potassium dichromate, DICHROMATE. Dichromate, you put Roman numerals 6. The 6 we got from here just now. Dichromate 6 ion. The orange color is always orange in color. Dichromate 6 is orange in color. Potassium or manganese 7 ions purple. You have to remember that. So you put down is reduced. I put R, you write in detail. Is reduced to form, okay, this one. Even chromium, chromium also got chromium +2, +3, +6 and all that, the oxidation state, but it's 3+. So you put chromium, CHROMIUM, chromium. Put Roman numerals 1, 2, 3. You can see 3+ there. Chromium 3 ion.
Sure.
This 2 just now you have to.
Sure.
Yes, I repeat again.
Sorry, I got a question.
Yes. Who's this?
Is it possible for transition metals to have negative ions?
No.
So only positive ions are?
All positive. The charge is always. There's no negative. Because they are metals, Non-metals only have negative. Remember O2 minus, N3 minus, Cl minus. Because these are metals. Metals cannot have negative. Must be positive. But transition element, they have more than one. That's why you must do. You say chromium ion, wrong. Because so this one label, this is a dichromate 6 ion. Write down. The dichromate 6 ion. Put orange color there. Must know. This one is chromium 3. This one here. This solution here. Chromium 3 ion. Don't forget the Roman numeral. CHROMIUM. Okay, so we are looking at this now. So this only one way, orange to green. So I've just put the arrow this way. So it's reduced. This one reduced, right? Orange solution changes to green. Color change is from orange to blue. Must know this, huh? Telling you. Okay? Alright? Done, huh? If you do this, whatever we learn today is going to be used in the next lesson. You can ask Satish, you can ask all the people, they will know. Okay? Alright? It's going to be used in the next lesson. So it's very important. Alright? You know what we have done today. This one, okay, we try this, huh? Okay. Okay, this one, actually we study redox, but under displacement, huh? Okay. This is for this. Okay, you can see. Okay, this one you can see one element only, no problem. Okay, one try. Okay, one element only, no problem. Huh? Let me just check first. Who's Section one try now. Or Ming Chun? Oh, Kavin Bhaskaran. One try lah, Kavin. Anyone? Try. One try now. This one.
Cu2 plus 2e.
No. Tell me what type of reaction is it? What type of reaction?
Reduction.
Okay, reduction. Write down reduction. Okay. All right. Good, huh? Okay. How you describe in words?
Copper 2 ions have been
copper ion wrong. Copper 2 ion is what?
Reduced to form copper 2 atom.
And no copper 2 atom. Just copper atom. Talk in terms of particles. Huh? Very good. Copper, write it down. Copper 2 ions is reduced to form, that's the question here, copper 2 is reduced to form copper atom. You put copper, nothing wrong, but just put copper atom, because we're talking in terms of particles. Okay, next one? Well done. Okay, then observation. What color is it? Blue solution, all right, okay, becomes what? Can you see I'm going to zoom in. When copper is formed, you can see a brown solid there. Can you see that? This is blue solution, this is copper 2 ion. When copper 2 ion becomes copper, I think blue solution turns what? Don't bother this solution, turns brown. Alright? Okay, write that down. Blue color solution becomes brown solid. This is reduction of copper 2 ion to form copper. Very famous. Okay, this one we don't learn in redox, but we learn it in electrolysis. But it's still, okay, this is opposite. Okay, who wants to try in words? Check one, try. What type of, okay, what type of reaction is this? Which one? Try, Sean. What type of reaction?
Okay. This is oxidation.
This is oxidation, 0 to +2 oxidation. Okay, so I put in
copper atom oxidizes.
Copper atom is what? It's oxidized
to form copper 2 ions.
To form copper 2 ions. Well done, very good. Okay, so the copper plate, this one is observation when you do electrolysis. Okay, this one will be type of electrodes, where the copper plate will dissolve. You see, I put this one, put brackets, I put electrolysis. We describe this in electrolysis. Okay? Alright. So done. Okay, so far okay, I don't think I finished today. Okay? But okay, now we do the first one. Okay, this one is extremely important. Okay, ready? In chemistry, for our SPM syllabus, there are only 3 famous oxidizing agents. When you go for A levels, when you go for higher level matriculation or SAM or whatever, you will study other oxidizing agents. There are so many oxidizing, and this topic is a continuation in your redox, in your A level. Other different type of oxidizing agents will come in. But for SPM, only 3. Understand, so whatever you learn here, the foundation is important. When you go for A levels, your lecture will just continue on what, assuming you know all this. He's not going to explain all this like what I'm doing now. They will just carry on, So if that's why students who are weak, they go for A level, it's blur, very blur for them, because they cannot understand. Because they lack the SPM foundation. Okay, ready? All right. So the 3 famous oxidizing agents. First one is all the halogens. The 2 halogens is this 2. They don't take fluorine, they won't ask for fluorine, neither will they ask for iodine. Because iodine is a very weak oxidizing agent, so no need. Only stick to aqueous chlorine or aqueous bromine. Aqueous chlorine is the pale green solution, bromine is the orange color solution. Or brown, brown. Aqueous bromine, you can put orange or brown also can. You can even put here either orange or brown. Okay. Alright, whereas aqueous iodine is brown. This is my mistake. Okay, aqueous iodine is brown. Okay, that one you know. Aqueous bromine is brown or orange also can. Aqueous iodine is brown, that's what I showed you. Aqueous chlorine, note it down, is pale green. But iodine they won't ask as oxidizing. Only, alright, bromine and chlorine. Okay, first oxidizing agent. The second one is acidified potassium manganate. You don't say potassium manganate, there must be acidified. Highlight that one. It's another oxidizing agent. What color? Purple. We take the potassium manganate 7, you just add some acid to it. So acidified. The third oxidizing agent is acidified potassium dichromate 6 solution. You know why it's 6 and 7, I just told you. What color is it? The orange color. Okay? For those of you who have a color printer, if you print out to this worksheet, you can see the color. Okay. Alright, ready? Okay. Alright, we are going now to the first one. Okay, it's almost 2:56. Or shall we continue the next lesson because it's quite long. Alright, or you want to continue now or what? What do you think? Satish? True? But it's quite long, you know. Okay, and then we have to describe this. Okay, so never mind, I think we'll continue the next lesson. Okay, so we will next lesson, okay. So this small part you use for next lesson, you bring it next lesson, and then I'll give you another worksheet for the other color changes, and we're going to describe this time adding an oxidizing. It's like this, or for the next lesson, okay. It is adding an oxidizing agent to a reducing agent. Understand? We have to describe what happens, what we learned earlier, right half observation, right half equation, okay, all that. And identify which is oxidizing, which is reducing agent. Okay? Alright, this one when you all come back next week, we will do it in the lab. Okay, so I think we'll call it a day today. It's almost 3 more minutes only. Okay, yeah? Alright. Any question for today?